This question tests the ability to evaluate inventory ordering decisions when quantity discounts are available. Instead of considering only ordering costs and carrying costs, the purchasing manager must also consider the cost of discounts lost by choosing a smaller order quantity. Valley Incorporated uses £400 per year and orders £50 each time, resulting in 8 orders annually. Since each order is between £30 and £79, the company qualifies for the 2% supplier discount. However, if it ordered £80 or more, it would qualify for a 6% discount. Therefore, by ordering only £50 each time, the company forgoes an additional 4% discount. The total relevant cost includes 3 components. Ordering cost. 8 orders at $200 each equals $1, $600. Carrying cost. With an order size of £50, the average inventory is £25. At $100 per pound, annual carrying cost is $2, $500. Discount lost. The company purchases £400 at $500 each, totaling $200,000 annually. Foregoing an additional 4% discount costs $8,000. Adding these components gives a total annual cost of approximately $12,100. A. $1,600. Incorrect. This includes only ordering costs and ignores carrying costs and the lost quantity discount. B. $4,100. Incorrect. This includes ordering and carrying costs, but ignores the substantial discount lost. C. $6,600. Incorrect. This understates the total relevant cost by failing to include the full value of the lost discount. D. $12,100. Correct. This reflects the combined impact of ordering costs, carrying costs, and the additional supplier discount sacrificed by ordering only £50 at a time. Correct answer. D. $12,100. Exam tip. In quantity discount problems, do not evaluate ordering and carrying costs alone. Always consider whether ordering larger quantities generates purchasing discounts that outweigh the additional carrying costs, since the lost discount can be the largest component of total inventory cost. This question tests understanding of inventory carrying, holding, costs in inventory management. Carrying cost represents the annual cost of maintaining inventory and typically includes storage, insurance, handling, obsolescence, and the opportunity cost of invested capital. The question provides several pieces of information. Annual usage, 48,000 gallons cost per gallon, $12 carrying cost rate, 20% of purchase price order size, 2,000 gallons safety stock, 2,400 gallons lead time, 3 days. Students should recognize that lead time is not needed for calculating carrying cost because the question asks only for the annual cost of holding inventory. Instead, the relevant inventory is the average inventory held. With an order size of 2,000 gallons, the average cycle inventory is 1,000 gallons. Adding the 2,400 gallons of safety stock gives an average inventory of 3,400 gallons. The annual carrying cost per gallon is 20% of $12, or $2.40 per gallon. Multiplying this annual carrying cost by the average inventory of 3,400 gallons gives an annual inventory carrying cost of $8,160. A. $2,400. Incorrect. This ignores safety stock and understates the inventory being carried. B. $5,280. Incorrect. This reflects an incorrect calculation of average inventory or carrying cost. C. $5,760. Incorrect. This considers only part of the inventory held and excludes the full effect of safety stock. D. $8,160. Correct. The company holds an average inventory of 3,400 gallons, and at $2.40 annual carrying cost per gallon, The total annual carrying cost equals $8,160. Correct answer. D. $8,160. Exam tip. When safety stock is maintained, it must be added to average cycle inventory when computing carrying costs. Also, lead time affects the reorder point, not the carrying cost calculation, unless the question specifically asks about reorder quantities or inventory levels during replenishment. This question tests understanding of safety stock, an important concept in inventory and working capital management. Safety stock is extra inventory held above expected demand to protect against uncertainty in demand or supply. Its primary purpose is to reduce the risk of stockouts, ensuring that customer demand can still be met when unexpected events occur. Safety stock is especially useful when supplier deliveries are delayed, customer demand fluctuates unexpectedly, seasonal events, promotions, or weather conditions create unusual sales patterns. However, safety stock cannot protect against structural changes in the market, such as a permanent decline in demand caused by new competitors. In such cases, holding additional inventory may actually increase carrying costs and the risk of obsolete stock. The question asks for the situation against which safety stock does not provide protection. Customers cannot find the merchandise they want, and they will go to the competition. Incorrect. Safety stock helps prevent stockouts, reducing the likelihood that customers will leave because products are unavailable. B. Shipments of merchandise from the manufacturers are delayed by as much as 1 week. Incorrect. One of the primary purposes of safety stock is to provide inventory during unexpected supplier delays. C. The distribution of daily sales will have a large variance due to holidays, weather, advertising, or weekly shopping habits. Incorrect. Safety stock is specifically designed to absorb fluctuations in customer demand caused by unpredictable factors. D. New competition may open in the company's market area. Correct. Safety stock cannot protect against increased competition. New competitors affect market demand, not inventory availability, and holding extra inventory will not solve this strategic business problem. Correct answer. D. New competition may open in the company's market area. Exam tip. Safety stock protects against uncertainty in supply and demand, such as delivery delays or unexpected spikes in sales. It does not protect against long-term strategic risks, including changes in consumer preferences, economic conditions, or increased market competition. Distinguishing operational risks from strategic risks is essential in inventory management questions. This question tests understanding of the economic order quantity (EOQ) model, a fundamental inventory management tool used to determine the optimal order size that minimizes the total cost of inventory. The EOQ model balances ordering costs against inventory carrying costs. Conceptually, higher ordering costs encourage companies to place larger orders less frequently, increasing the EOQ. Higher carrying costs encourage companies to hold less inventory, reducing the EOQ. Higher purchase prices increase the dollar value of inventory and usually increase carrying costs, leading to a lower EOQ when carrying costs are based on inventory value. Safety stock is extra inventory held to prevent stockouts and affects the reorder point, not the EOQ itself. The question asks which variable, when increased, would cause the EOQ to increase. Students should focus on the relationship between ordering costs and order frequency. A. Carrying cost rate. Incorrect. An increase in carrying costs makes holding inventory more expensive, so firms reduce order sizes and the EOQ decreases. B. Purchase price per unit. Incorrect. A higher purchase price generally increases the cost of carrying inventory, encouraging smaller order quantities rather than larger ones. C. Ordering costs. Correct. If the cost of placing an order increases, the company will prefer to place fewer orders, each for a larger quantity, causing the EOQ to increase. D. Safety stock level. Incorrect. Safety stock provides protection against uncertainty, but does not affect the optimal order quantity. It influences the reorder point rather than EOQ. Correct answer. C. Ordering costs. Exam tip. The EOQ increases when annual demand or ordering costs increase because larger orders reduce the number of expensive purchase orders. Conversely, EOQ decreases when carrying costs increase, since firms seek to minimize the amount of inventory held. Remember that safety stock affects when to order, while EOQ determines how much to order.